Yep, so we need to look at number 8. So when you make the perfect square with this, what type of a conic section comes out? So it's hmm, okay. So something like this. So, yep. So what's the type of a conic section for the first parenthesis? Can you hear me?
Mhm.
Yep. For the first parenthesis to be zero, which shape is for this equation? A
Circle.
circle. So there should be a circle here. How about the second parenthesis? Something like this. When squares are subtracted, that makes parabola or hyperbola. Let's make a graph of this if we are not sure about this. Yeah, let's check with the graph. So if we make the second graph, yep. What's the name of this graph? Shape of this graph?
Is that a hyperbola?
Yeah, hyperbola. Hyperbola. So circle and a hyperbola is the answer. But for number 9, let me copy this. Let's see. So at first, let's divide both the sides by this 2 to the power of 27, and that makes the exponent this negative. So this means the value of this seventh term, a7, is the power of 2. And because it's a positive integer, I mean, this a7 minus 27 should be greater than 0, or greater than or equal to 0. So a7 should be the power of 2, greater than 27. And so uh, because we want to find the minimum value, what will be the minimum power of 2 greater than 27? When you think of this power of 2, which one is greater than 27? 8 is here. So the first value, greater than 27, occurs when uh, a to the fifth power, 32. So we can start with this. The a7 is 32. And then, so that means to make to make a7 from a0, because it's arithmetic sequence. If we add the common difference 7 times to a0, that will make a7. But a7 is 32, so that means a0 is 32 minus 70. But a0 is also should be positive integer, so that means this should be greater than 0. So what will be the value of d satisfying this inequality? So 70 is less than 32. So in this case, we are talking about largest value of d because of this negative sign that makes the value minimum. Yeah, 4. Yeah, okay, so
Yeah.
4. Yeah, integer value 4. So now, so the common difference is 4. So that means when d is 4, a0 is also 4, and then we keep adding 4 to the sequence. So what will be the value of a2? So a1 is and a2. Can you find the value of a2? If we keep adding 4.
12?
Yeah, 12 is the value of the a2. For number 10, so let's make a regular hexagon. Side length is 2. And then yeah, the vertex for A to F, and G is the midpoint of AB, and H is midpoint of DE. So if we make a quadrilateral GCHF, we want to find the perimeter of this quadrilateral, and because the outer triangles, these outer triangles are all congruent, so that means these lengths are all equal. So that means this quadrilateral is a rhombus. So after finding one side length, we can just multiply 4 to the side length. And to find the side length, let's say the side length is L. And because the hexagon's side length is 2, and the angle is 120 degrees, so we are going to use the law of cosine. So that means L squared is equal to 1 squared. Do you know the value of cosine 120 degrees? Yeah, do you know
120.
cosine 120 degrees?
Wait. Great. What was sine 30 again? I forgot what sine 30
but
was.
you can use calculator, use degree mode, find the value of cosine 120 degrees.
Yeah, negative 1/2.
Negative 1/2. So that means we can cancel this negative 2. So that means it's like 5 plus 2, so 7. So side length of this rhombus is square root of 7. So what's the perimeter of the rhombus?
4 square root
Yeah,
7, so
4
D.
root 7. Yeah, D. Yeah. Yeah. Yes. And number 11. Yeah, for this problem, we are going to use some complex number. So there is Euler's formula like this: e to the power of I theta is something like this, and we previously saw the value of the cosine 120 degree. That's minus 1/2. So that means the first one, the theta value is the 120 degree, and in radian, that's the 2 pi over 3. So f of n is mm, like this. That's the first parenthesis. And for the second parenthesis, because of this negative sign, we can think of that the negative 2 pi over 3, like this. So if we make the nth power, and we want to find this 2022, so if we multiply 2022 to this 2 pi over 3, 2022 is the multiple of 3, something like this. Yeah. So we can multiply this to 2 pi, and that's minus 2 pi times 674. But I mean, because it's a multiple of 2 pi, multiple of 2 pi in this case is equal to 0. I mean, cosine 0 is equal to cosine 2 pi. So in such case, we can think of this value is just 0 because that's a multiple of 2 pi. So that makes the exponent is 0. So both the exponent is 0. So what's the sum of these two values?
Two.
Yep. So the answer is E. Where is? Which state do you go to when you go to college?
Which state will I go to, or which state do I want to go to?
Oh, yeah, I mean, I think you are going to the Boston, right? I mean, the eastern part.
I wish. I wish.
Okay, yeah, you wish. Yep. Yep.
I want to, but all the
Oh,
schools there are like really good, so
I
and I'm not
see.
really a good student, so
Okay. Okay. Yeah. But I think you will definitely will go to maybe more like the tech university, right? I mean, uh,
Mhm.
yeah. Yeah. Let's see. Number 12. Keller. Okay. Uh, One of my students wanna study in Texas, so I think he's thinking of. I mean, Tesla is in Texas, and I think there are some good university in Texas. So, Austin.
So like
Yeah.
Austin,
Yeah.
Rice, and maybe Texas.
Yeah, I think maybe Moscow may set up some university in Texas because the factory is in Texas. Mm. So I hope that's possible. That comes soon.
Hmm.
Yeah. Yeah. So let's see. I think we need to think of a complement to solve this problem. So the complement means so the first event. Let's just say this is A and this is B. So A's complement. A's complement means no number is greater than 4, right? No number is greater than 4. That means all numbers are made of 1 through 4 when you roll up dice. So the number of case for this is because he rolled the 4 times the 4 to the fourth power. All dice are made of the 1 through 4. And for the B's complement means at least two. Uh, that means no number or one number is okay. No number or one number uh, is greater than two. So let's first think of the case when no number is greater than two. That means all numbers are made of 1 and 2. But this case is already included in this A's complement, so we don't have to think of this twice. That's redundant. And let's think of the second case when only one number is greater than 2 means uh, we can think of four cases, 3, 4, 5, and 6. One number is made of one of these, and then the others will be made of 1 or 2. The other three numbers. It's like this. But once again, these two cases are already included in A's complement because in this case, all numbers are the less than or equal to 4. So we don't have to think of this case. So we need to think of when one number, only one number, is 5 or 6. So the number of cases is 2. And then we can think of the position of this number. It can be one of the four roll. So that's number of cases 4. And for the rest three numbers, it's made of 1 or 2. So for that, we are multiplying the 2 cubed. So that's from the B's complement. So we can add these two numbers and subtract this from the total case. Uh, so at first, what is 4 to the fourth power? Yeah, when you multiply four times,
2, 5,
yeah,
6.
2, 5, 6, and the second product is it's like 8 times 8, right? This is 8 and 8. So so 64. So add these two. What's the sum of these two? That's 320. And the number of total cases is 6 to the fourth power. And so we are subtracting this complement from the total probability. So when you simplify this, it's like we can divide both the numerator and denominator by 16 like this. Yeah. So what's the
Sorry, sorry.
okay,
I
okay.
think my mic just cut off for a
Okay, yeah,
sec.
yeah. So yeah, subtract this complement. So uh, can you find in the choice in the fraction in the choice? It's like 20 over 81. So yeah, can you subtract 20 over 81? Yeah,
D.
D. Yeah, 61 over 81 is the answer. For number 13, we can use a Pythagorean theorem because this is a square. So 5, 4, right? Yeah, so subtract these three triangles from the rectangle that will make the area of the shaded region. So what will be the answer? No, sorry, this is 4. Yeah, this is 4. Something like this. Yeah, can you find the answer for the from the choices?
D.
Yeah, D. Yeah. For this problem, number 14. Yeah, so we need to find the x and y intercepts. So y-intercept is 0 and minus 15. Let's make a graph of this. Something like this. Yeah, the x-intercepts are minus 5 and 3. Uh, so we can make this triangle using these points. So A, B, C. And we want to find the tangent value of this A, B, C. So we can divide this tangent, this angle, this into two types. Let's say theta 1 and theta 2. So what will be the value of tangent to theta 1? I mean, adjacent and opposite over adjacent. That's 5 over 15 in this left to right triangle. So 1/3. And what's the value of tangent theta 2 for the right, the right
1
side?
fifth.
Yeah, 1/5. And we want to find actually the tangent of this theta 1 and theta 2. So I'm going to use some formula for this. This is it looks like this for the addition of a tangent. So if we put these fractions, yeah, can you simplify this fraction? So multiply 15 to both the sides. No.
E.
Yeah, the 4/7. Yeah. For 15, so let's just start with choice A. The number in choice A is not a multiple of 2 because it's just it's odd number. Right? And how about uh, for the multiple of 3? I mean, we are looking only at the last digit. So that means when this one is divided by 3, the remainder is 2. And this makes the remainder is 1. So if remainder of 1 comes out, that means it's alternating between 2 and 1. So that means because this 606 is the even number, the even power makes the remainder 1 when it's divided by 3. So it's like 1 minus 1. So remainder is 0. That means this number is a multiple of 3. So that's not the case we want. We want to find not divisible by any prime number. And in the case of B, it's not a multiple of 2 and not a multiple of 3 because 1 plus 1 is 2. So remainder is 2 when it's divided by 3. So we can test the next prime number, the 5. So if we test, if we're only looking at the last digit, when it's divided by 5, when 8 is divided by 5, the remainder is 3. Now 1 comes out, so that means for the remainder when divided by 5, this has a cycle of 4. And because 606, uh, the remainder when it's divided by 5 is 2, so it follows this one. So the remainder is 4 plus 1 is 5. That means it's a multiple of 5. So B is also not the case we want. And in the case of C, so it's not a multiple of 2, and because it's odd power, when it's divided by 3, the remainder is 2. 2 minus 1 is 1, so it's not a multiple of 3. And when 607 is divided by 4, the remainder is 3, so that means when it's divided by 5, the remainder is 3. 3 minus 1 is 2, so it's not a multiple of 5. So we need to test the next prime number, the 7. So if we follow the last digit when divided by 7, when 8 is divided by 7, the remainder is 1. So that means now the remainder cycles between among these three. So that means 607 when it's divided by 3, the remainder is 1. So that means the remainder is 2. So 2 minus 1 is 1. So that means it's not a multiple of 7. And we used up all the prime number less than 10. So C is not divisible by any prime number less than 10. So the answer is C. And for number 16, we need to use a logarithm. So at first, let's apply the log of 2 to both sides of the first equation. That makes y comes out of the log. So the left side is y times log 2 of x. And for the right side, the log of 2 cancel this base 2, so only 64 remains. And in such case, we can substitute the 64 over y for the log 2 of x in the second equation. So when we do that, that makes 64 over y to the power of log 2 of y equal to 2 to the 7th power. And once again, we are going to apply the log 2 to both sides. That makes this log 2 of y comes out. And in the case of a log, this division becomes a subtraction. So log 2 over 64 is 6. And for the right side, the base 2 cancel, so only 7 remains. So let's say log 2 over y is equal to the capital Y. So 6y minus y squared is 7. So and then we can complete the square to find the value of this capital Y. So, yep, so which one is the greatest value among these two, between these two?
C.
Yep, C is the greatest value. And for this problem, let's make a case. I mean, one example looks like this. Something like this. So now the rows sum is 1, 2, 3, 4, and columns sum is also 1, 2, 3, 4. So to do that, we need to make one row filled with 1 and one column filled with 1. So we need to choose the row and the column. I mean, there are 4 possible cases, 4 rows and 4 columns. So the number of choices is 4 times 4. And then we need to fill the rest 9 position with these 3 ones. So for the remaining this 3 by 3 grid, we need to choose which one has the 2, 1, and which one has 1, 1. So the number of choice is 3 times 2. And then let's say we pick this column having the 2 ones. In such case, this is 0. 0 can move one of these 3 position. So the number of choice is 3. And then after setting this one should be one of it, adjacent to one of these ones. We cannot make one here like this. That's not the case we want. So that means this one's position should be one of these two, adjacent to one of these two. So that makes the choice 2. So you can multiply all these numbers. So what's the product of these numbers? So it's a kind of perfect square. 4 times 3 times 2 is a perfect square is
576.
yep. For this problem, it's hard to explain. Oh, what is going on? Yeah. So, let's start with the center is filled before this transformation, and for this center should be kept filled. Mm, uh, it should have 2 or 3 filled neighbors. That makes the filled square remain filled. So let's say it like this. We need to fill 2 squares. I mean, neighbor means this inside it is 3 by 3 degree grid. And then, so if we think of this 3 by 3 grid, this one starts with a field, but because it has only one neighbor field, after transformation, it will be empty like this. So this configuration is okay. This one too. In this grid, when this one is filled, it has only one the neighbor field. So that's why after transformation, it become empty. But in this center grid, looking at this one, it has 2 filled neighbors, so that's why it remains filled after transformation. So this is one type of configuration possible. So when 3 squares aligned diagonally, that makes the only one center square filled after transformation. So we can make these 2 types of the diagonal. So there are 2 cases when the center starts with a field. And let's think of the case when center is empty and after transformation it should be filled. So to make empty field, empty in the case of empty square, it should have the 3 filled neighbors. So we need to make three filled squares around on this empty square. So one configuration is like let's fill these three corners and let's see if that works. So now if we look at this 3 by 3 grid, uh, this filled center does not have any neighboring filled squares, so it will become empty. To remain filled, it should have 2 or 3 filled neighbors, but 0 neighbor makes this one empty. I mean, other things too. I mean, if we look at this grid, it will be empty after transformation, or this one will also make this empty. Yes, and then this empty square has these 3 filled neighbors, so that's why it becomes filled after transformation. So this configuration works. And we can rotate this configuration the 90 degrees, so there will be total 4 number of cases. And then maybe we can move one of these to edge like this, right? And still this empty square will be filled because it has 3 filled neighbors. And for this grid, uh, uh, this this will be uh, uh, empty. It starts with a field, but it has only one field neighbors, so that's why it becomes empty after transformation. And this one too, this field square will be empty because it has only one field neighbor. So this configuration is okay. And if this works, this will work too. So uh, for this corner, we have this 2 configuration, and we can rotate this. So in this arrangement, we will make this 8 number of cases. And then let's say uh, one edge, and 2 corners like this. So each of them has 0 neighbors for the 3 by 3 grid. So these 3 will all empty after transformation, but the center will be filled. So this one also works. And in this case, we can rotate these edges 4 times. So once again, we can make 4 number of cases. Yeah, so that's the case we can think of. So, no, and then this one, 2 edges and 1 corner. 2 edges and 1 corner like this. So, for this grid, this one will be empty because it has only one field neighbor. And for this one will be empty because it has only one field neighbor. And this one will be also empty because it has a 0 field neighbor, but the center is filled. So this one also works. And we can rotate this 90 degrees, so 4 more. So now watch the sum of these 5 numbers.
22.
Yeah, 22 is the answer. Hmm. Yep. In number 19. So let's make a triangle ABC, and we are going to make two medians. So let's ABC. So ABC and AD and B is a median. So that means this G is the centroid of this triangle, and AGE is equilateral. So let's say this length are all 1, for example, because they are equilateral. Let's say it's 2 instead of 1. It can make things more easier. Like this. And because the G is a centroid, that means the G divides the median with a ratio of 2 to 1. So that means this will be 1, and this BG is 4. The ratio of 2 to 1 means. And then uh, this angle is 120 degree because it's a supplement to the 60 degree. So we can use the law of cosine to find the length of AB. So AB squared is and cosine 120 degrees minus 1/2. So that's 28. And then this one is 2 because E is the median. So AC, the length of AC is 4. And so for the length of BC, we can also use the law of cosine. The B's length is 6. AC is 2. Once again, this angle is 120 degree. Hmm. 12. Yep. So we know now all the three side length, and then we can use this. We can find the value of cosine C. So cosine C is like AC squared is 16 plus BC squared is 52, and subtract AB squared, and then 2 times AC and BC. What is going on? Yeah, so this is the value of cosine C. So when you add these three numbers, what's the sum of these three? Can you find?
44.
Yeah, 44. Yeah, so it is the answer. For number 20, Yep, so P of x is divided by this polynomial x squared plus x plus 1, so that means so there will be some quotient, and then the remainder is x plus 2. But we want to find the polynomial of least degree. So to have the least degree, we can start with the linear function, something like this. That makes the degree the smallest. We can even think of the constant, but that doesn't make sense for the second condition. So we can start with the linear function. And so if we open this parenthesis, we have this expression. And when this same function, the polynomial is divided by x squared plus 1, the remainder is 2x plus 1. So that means we can make another factor from this. That means so we can change this one to this form. And now we don't have to think about this. That's incorporated to this x squared plus 1. So the remainder is 2x plus 1. So this should be equal to 2x plus 1. And that means q is 1 and p is also 1. So we can put these values. Now we can construct this p of x. So when you open this parenthesis, so the total expression is so this is p of x. So if we make the sum of a square of a coefficient, so 1 square, 2 square, like this. Yeah, what's the sum of this? Something like this.
23.
Yeah, 23. So the answer is E. What is going on? Okay. Oh. And 21. I think we can make the graph to understand the situation. So let's make these 3 circles using Desmos. What is it? So the first one, and for the second circle, 64. What is going on here? It looks like ellipse, but it's a circle. How can I say? Maybe yeah, I should say this way. Why?
Try clicking 정사각형 확대 slash 축소.
Where
maybe?
is it? Yeah, this one. Okay. Oh, okay. That looks good. Okay. Yeah, now it looks circle. Yeah, like circle. Yeah. Okay. Yeah. And then let's make third circle. Okay, so now we have these three circles, and we want to find the circle tangent to all of these three circles. So if we think of such a circle, we can think of this type of a circle, right? So now this circle is tangent to three these circles. So you can think of the bearing inside this wheel. And when this bearing rolls, it will be tangent to this green circle, the smallest circle, and it will happen 4 times. This is first case, and it can penetrate. It's hard to make circle. Let me see. Why it's not working? Oh, okay. So yeah. So the second one is like this, and then as it passes through, like this. No, it's always attached to the blue and red circle, but it will be tangent to this smallest circle 4 times as it rolls around this wheel. That's one type. And the second type is a kind of bigger circle. Bigger circle means it contains both the red and green circle on the inside, and so this one is like the hula hoop, right? So it also happens like this. Yes, so the bigger one is like this. So the property is that this one always touches the center red circle, the inside. So it also happens 4 times like this. And so the first case, the circle's diameter is the difference of these two radius. So the radius in this case is 6, the diameter is 6, so the radius is 3. So that means the area of the circle is 9 pi, and it happens 4 times. And for the bigger circle, we are adding the radius of these two for the diameter. So that's the diameter is 10, and the radius is 5. So 25 pi is the area times 4. So what's the sum of these two? So that makes the 136 pi. That's the sum of the area of the circle. Yep, so the answer is E. Yep, so I think that's enough for today. So let's talk about the next schedule. I send you the talk tomorrow. And do your homework. Yep. 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 So that's it for today. So see you next time.
Thank you.
You're
Bye.
welcome. Yeah. Bye. Have a good day.
You too.
Yeah. Bye.